Hello, everyone. My name is Phil Sands. I am the former K-12 outreach coordinator for computer science at Purdue University, and I'm here to help you through some basic first steps towards programming and teaching programming in your science classrooms. We have a number of sessions that we're going to take you through. All of them use some tools that are free and readily available through various websites. We're going to try and give you a basic sense of how to use them, really just kind of a push in the right direction. And then we will give you some resources so that you can continue to do this kind of work with your students. Before I got into the actual teaching of some of these ideas, I wanted to spend a few minutes talking to you about computer science. And if you feel like you already have a pretty good handle on what computer science and computer programming is, you can go ahead and move on to the sessions in the other videos that follow. But I do think that there might be a few tips I can offer, and so it might be worth you taking a few minutes and watching this video. Before I go too far, I did want to introduce myself a little bit more. I've been teaching and involved in education since the middle of the first part of the century, from 2006 on, and then before that I was a computer scientist and a programmer. I spent a number of years just teaching math and eventually was asked to teach computer science. And through some happenstance, ended up down at Purdue, where I got to meet these excellent colleagues of mine who are with College of Science K-12 Outreach. And from there, I decided I wanted to go and learn a little bit more about how to work with students more effectively and how to work with teachers. So I've been on this for the past five or 6 years. I've been working on my PhD in education psychology and education technology, and I'm in a lab that actually studies CS education. We do research in that space. Thankfully, even though I'm no longer with Purdue, the wonderful people in College of Science Outreach asked me to help out with these sessions. So hopefully I can bring some of the expertise I've built up over the years to help you get started and really do some excellent teaching and encouraging of computer science and computer programming in your classrooms, and really give your students a tool that they can expand upon and build, and maybe even spark an interest that can lead them into a career that they might enjoy quite a bit. So really briefly, I just want to talk a little bit about what programming is, because I think, especially when you're starting, it seems to be a little bit mystifying. First of all, what you're writing when you write computer code is you write what we call high-level instructions. Those are things that need to be translated further by programs that we call compilers or interpreters, and those eventually end up in ones and zeros, which is called machine code. And that is what your computer or your smartphone or any other device that can read read binary language, that's what it eventually will use to execute instructions. And the instructions that a computer actually executes are not the same as the ones you write. The translation process does some interesting things. You don't need to know all that, but I think sometimes it helps to understand that there is a process, and that's why there are so many languages. And because I think there are so many languages, it can be really overwhelming at first because it's hard to figure out where to start. So that's why I wanted to talk a little bit more about this. Really, programming serves as this bridge between humans and computers. So we're the ones with the ability to tell the computer what to do. And oftentimes the hard part of computer programming is not necessarily writing the code itself. It's thinking about how we're going to give those instructions and designing the big picture algorithms and the structures that will do the work. So I always like to emphasize with my students that they're the ones with the knowledge. They're the ones that can think, and the computer does like the grunt work. It can do it really fast, and that's why it's powerful. And I think sometimes that's really empowering if you can tell the students that that's the part that they're going to play in the entire system of being a computer programmer. I mentioned there are many languages. Just to give you a sense of what some of the common languages are that people are using right now in 2021. General purpose languages you see are ones that can be used for a lot of different kinds of programs. So Java, Python, and C, very common, or C++, those are two related languages. You can use those and learn those, and if you do, I think you can probably learn many other languages because they all have common features. And really, it's just a matter of which one you want to start with. The AP Computer Science A course, for instance, uses Java, but I know a lot of colleges, and me personally, having taught programming a long time, I like things like Python because it removes certain things, and I don't want to go into too much detail, but it removes some of the things that make it hard to get started. Then if you go further, other areas that you could pick up a language, if you're making some kind of web app, something for your phone, something that you use by going to a web browser, you can use JavaScript, you can use PHP. There's a lot of languages in that space, and in fact, JavaScript has been built is underlying a lot of the tools that people are using nowadays. So they're more complicated collections of tools that you can use, and underlying all that is JavaScript. If you're doing a distributed program, one that like works over multiple computers, there are a lot of languages now, Go, Scala, Rust, and those languages all have other purposes too. Rust is known for its security. Go is one that Google has been using, so it has some optimization for working with Google tools. A lot of people, including myself as a researcher, end up using the programming language R, which can be used to do a lot of data and statistics. So if you have a mathematical interest, or you want to get your students some college level tools, you could even learn some R, which is a challenge. I tried to use it with my high school students to mix success back when I was teaching in the classroom. So, but it exists, and that's exciting to know that you could do that, and those are the kind of tools that we use at the college level as well. I mentioned some platform specific ones because some students really like their Apple products. If you want to work in that ecosystem, you have to use their languages or proprietary languages. It's a little bit of a steeper curve, I think, but Swift and Objective-C are those languages. And then lastly, if you just want to teach, which is I think what most of us want to do, and you're not so worried about them building the next great tool or the next great app, you can use some of these computer programming languages that were designed specifically for learning how to program. And those include things like Scratch or Racket or BASIC. I learned BASIC when I was much younger, and it still exists, so you can do that. But Scratch is a great tool, and we're going to use that in one of the sessions that I have planned out for you. The idea of Scratch introduces an interesting idea in terms of teaching. What you see on the left and right here are two different programs that actually do the exact same thing. The one on the left is written in Scratch. The one on the right is written in Python. And the reason why you might make a choice of using a block-based language versus a text-based language is one of the big challenges for teaching new programmers or for learning it yourself is going to be, in terms of a text-based language, are the possibility and probability of running into what we call syntax errors, meaning you have your ideas right, potentially, but the compiler, which is the program that translates your code, can't read what you wrote because it doesn't follow the very specific rules. Maybe there's a spelling error, or Python, which is the language that's being used on the right, has issues with spacing. So if you don't have the right indentation, it can be a problem. So there's a lot of things that go into that I think are overly frustrating for new learners. So if you use a block-based language where the language on the left, which is Scratch, you can actually assemble your code, and because of the way that the blocks get put together, you don't make the same kind of typing mistakes. There are very few opportunities for typing mistakes in a block-based language. So again, remove some of those initial frustrations, and then you can kind of build the enthusiasm until the students are ready to take on something like Python. That being said, I think as long as you explain that there's going to be some of that frustration, most students are willing to go through it. But it does make it a little bit more challenging when they run into errors, because you're going to be the one that they call on to try and help them find those mistakes. So just something to think about. So what are some reasonable goals? I think number one, you should just pick a language, whatever it is you're going to use. I know that the College of Science Outreach folks have done some workshops on Arduino, which is a programmable microcontroller, and you can program for that using a version of C that is designed for the Arduino, and you could continue to teach that, and that would be great. I have suggested already that you use Scratch or Python. Those are great languages too. I think sometimes when you switch between tools, that can sometimes overwhelm students. And so it might be smart to just make a choice. And as you gain more experience yourself, you can make decisions about whether you want to continue with that in a future semester or a future year. The next goal I think you should set is help the students be comfortable with the challenge of learning a new tool. And that means helping them figure out how to get help if they need it, and understanding that, you know, sometimes it is hard to adapt to a new tool and that you're going to have to spend some time, you know, figuring in the ins and outs. And it's not just going to be this magical transformation and you're going to be ready to go as soon as you put your hands on the keys. So again, I think a lot of students are understanding of that, but, you know, encourage them and, you know, even maybe admit some of your own struggles. I think that will help your students to learn. When it comes to what you're actually teaching, I would focus on the basic functionality of common programming ideas, meaning like there are so many things that every language will have in common, and I've listed some of those things on this slide here. So every language has some kind of variable, which is a way to store information temporarily. All languages allow you to do some kind of arithmetic, so learning the operators that you would type for each of the different kind of operations. Boolean logic, which is a way to decide whether something should occur or not based on true and false values. Conditionals, which are the construct that actually allows you to have branching in your program, meaning like if the conditions are one way, we'll execute this part of the code, and if they are not that way, we'll execute the other part of the code. And that allows your programs to be more interesting. Loops allow for repetition, which is a very big part of working with data. Functions allow you to write reusable bite-sized chunks of code. And I think that's a good practice to get in the habit of doing that, even though it's not required in many cases to write a program that uses functions. But I think it's a good way to think about breaking up your code. And then lastly, data structures, which is a way to manage lots of information, which I think is, especially thinking about us as science teachers, is an exciting part of working with a computer program, is doing something to work with data. Finally, I want to give a few tips because having done this for a long time, I've run into lots of problems and I've learned how to be a better computer science teacher, and hopefully some of these things will help you as you're getting started, because I think it's really daunting to want to teach something that you aren't an expert at. And I'm assuming many of you are not experts at computer programming or computer science yet, but you have to start somewhere. You know, taking that first step is a big, important part of the process. So here are my tips. First of all, be comfortable learning along with your students. Don't be intimidated by a student or two who had a parent who had them on the robotics team, and so they've been programming robots since they were 6, or somebody who built their own website and is kind of showing off a little bit in class. I think sometimes the mistake we get into is feeling like we have to have all the answers. And if you're willing to say right up front, hey, kids, I'm learning this too, so we're going to discover some of this stuff together. And if you learn a cool tip, maybe you could share it with me, or maybe you could share it with a buddy. You know, I think that's a more positive view for learning, and it certainly is going to help your students when they're tackling something that at times can be very frustrating when it doesn't work. Second, I think kids need to see more code. You know, they're going to be adjusting to it as you are, but if you have an opportunity to demonstrate how to do something, even with the flaws that you're going to, and the mistakes you're going to make, I think that goes a long way for kids, right? Because they're going to see how you do it, and they're going to be able to mime the things that you're doing. So if you can demonstrate your best practices, that's going to be a big, important part of this. So take a session and do the coding. You know, if you have a projector in your classroom, or if you're working here like in a remote setting, and you can do it with your screen share, do the coding with the kids. One big thing in programming is learning to use feedback. Feedback comes in the form oftentimes of the messages that the program, when it compiles, will give you, meaning it'll say like, hey, there's an error on line 32 and you need to go fix it, or else I don't know what to do. That's basically what the compiler will say. Sometimes the language is not as clear, but those are the kind of things that a compiler will say to you. Or you'll run the program, you'll expect it to do one thing and it'll do something else. These are all forms of feedback that you can use to improve your program. So teaching the students how to use that feedback is it's a powerful step, and it kind of goes with that idea that I know a lot of us like, which is like growth mindset. We want to get better, and we want to be open to learning new things. And one of the ways you can do that is using the feedback that you're getting from the system you're working with. I would celebrate all successes. If a kid gets a program to compile, that might be a success to celebrate. Or if, even if they do something that seems mundane at first, or especially to you after you've done a couple programs yourself, celebrate it. Give them that positive energy, and let them really build on their confidence. There's a lot of research that says that students' belief in their ability to do something carries them through a lot of adversity. So celebrate them, everything, and have moments where you're celebrating as a class because you got something to work, even if it feels silly. And then lastly, because CS has been a space that traditionally has served white and Asian males, and there's a lot of reasoning why. I don't want to get into a whole thing about that, but I think sometimes we implicitly encourage groups of students to participate in CS and discourage other groups of students from participating. And we are all part of the solution to that, I think, which is by encouraging everyone and trying to acknowledge where we might be leaning into one of our implicit biases. I don't think it's necessarily something to be ashamed of if you have accidentally done that. I'm sure I've done that, where I've discouraged a kid and I hadn't meant to, but I did because of something I said or some way I acted. And I think we can really make an impact on getting all kids to have success and enthusiasm if we are mindful of those things. I have some resources here that we're going to use. You don't have to write or copy any of these things down, but these are some of the websites that we're going to use while we're doing our sessions. And I wanted to give you access to those, so in case you want to look ahead. And I will, like I said, bring these things up when we are going to go use any of these tools. But these are the 5 things that I'm going to show you during our sessions here for this workshop. And generally speaking, I'm happy to answer questions. I don't know how many people are going to end up watching this. And obviously, in my head, if it's 10 of you, I'm happy to help all 10 of you. And if it's 500, I'm going to be in trouble. But in general, I obviously am really enthusiastic about helping people to get more comfortable with computer science and to learn to teach computer programming to help more students. My email is there. I'm phil@msu.edu. Don't ask how I ended up with that email. And also my Twitter handle's below, and you can get in touch with me that way. And without further ado, I think we're ready to get into our first activity. So I will see you there.